Hello everyone and welcome to the OneClass channel. My name is Donna and I'm a recent master's graduate from the Materials Science program from the University of Ontario Institute of Technology, also known as Ontario Tech University. So today we're going to go over some commonly asked questions in chemistry at the high school, college, and university level. So if you needed any help with homework or with tutoring, then check out the links in the description below. Now let's just get started on our set of questions for today's session. Okay, so question 1 says that the sulfate ion SO4 2- can be drawn in many ways. If you minimize the formal charge on the sulfur, how many sulfur-oxygen double bonds should you draw in the structure? Okay, so let's start off by drawing a Lewis structure of the sulfate ion. And when we write Lewis structures, we first need to find out the total number of valence electrons for this ion. Sulfur contains 6 electrons, and oxygen also has 6, but since there are 4 oxygen atoms, we multiply this by 4. And also the overall charge of this ion is -2, so we need to add an additional 2 electrons to this count. Okay, so in total we have 32 valence electrons. So now let's draw sulfur as our central atom. And then I'm just going to draw 4 single bonds to the oxygens. Okay, so notice how none of these oxygens have a full octet yet. So I'm just going to draw 2 double bonds, 2 of them, and fill in the lone pairs. So I know that single bonded oxygens will contain a negative charge, and I know that the double bonded oxygens will be neutral. So another way I can double check that is by calculating the formal charge. So for the formal charge of an ion, it's equal to the number of valence electrons minus the number of non-bonding electrons minus the number of bonding electrons divided by 2. Okay, so now that we know this equation, let's check out the formal charge of a single bonded oxygen. Oxygen has 6 valence electrons, and a single bonded oxygen contains 6 non-bonding electrons. And there's only 1 bond to the oxygen, and each bond contains 2 bonding electrons. So we'd write in 2 divided by 2, and that's how we get -1. So I can draw charges of -1 beside my single bonded oxygens. Okay, so let's double check the formal charge of a double bonded oxygen. Again, there are 6 valence electrons in oxygen, and then double bonded oxygens have 4 non-bonding electrons, and they have 2 bonds, so it's 4 divided by 2, and they are neutral. So now let's check out the formal charge of the sulfur. Sulfur has 6 valence electrons, and this central sulfur atom doesn't have any lone pairs. So we subtract 0, and then we need to count out the bonds. So there are 6 bonds to sulfur, so that means there are 12 bonding electrons divided by 2, and sulfur is neutral as well. Okay, so we have the following Lewis structure, and we can also draw a resonance structure for this as well. So I'll draw some examples of what the resonance structures might look like. We might have a double bonded oxygen here and make this single bonded. Like that. And it's basically just experimenting with all the different ways double bonds can be formed for this ion. Okay, so here's an example of 3 different resonance structures. And the last part of the question says if you minimize the formal charge on sulfur, which we did, how many double bonds would you draw on this Lewis structure? So therefore we can draw 2 double bonds to minimize the charge on sulfur. Okay, so let's see what the junior tutor said. Formal charges happen when more or fewer electrons are present in the valence electrons of the atoms in the Lewis structure than the individual atom's valence electrons. An increase in valence electrons would mean that the formal charge becomes more negative, and while a decrease in electrons in the valence shell makes the formal charge to be more positive. For the sulfate ion, the Lewis structure with the least formal charge is, and they found out the total number of valence electrons first, it was 32, and they drew a Lewis structure with 2 double bonded oxygens, which is letter C. Okay, so this solution is correct.